Okay, so today we'll talk about how we draw molecules, how we can represent them, so the formulas we can use for this. So this formula will help us to know what is the constitution of the molecule, meaning what kind of atom we have and how many of each kind we can have into the molecule, and we can still know the shape of the molecule that will help us to understand the physical and chemical properties of these molecules. But it's something we study further this year or next year maybe. So the first one is the empirical formula. So you have the French translation just there. Sorry, this one. So how you can see is something you already know. I think it's about the kind of atom you have and the number of them. 4C, 10H, 10, 10C, 22H. So as you can see, we have the constitution, but we don't know how these atoms are bonding together. So just the only thing you have to know is this type and number of atoms. So now let's talk about the structural formula. How you can see with the name is about the structure of the molecule. So we can see all the bonds we have into the molecule. Each atom is linked to or bounded to another one, so we can see the bond. We could add this one between O and H, so we have all the bonds. And you can see something new. We can add something about Lewis. We talk about it, about Lewis formula. They'll say that we need to have 8 electrons, meaning 4 lines around each atom, or 2 electrons, meaning 1 line. So 2 electrons is just for hydrogen, that makes just 1 bond. So you have 1 line around H, meaning you have 2 electrons, so the rule is respected. Now if you talk about carbon, as you can see you have 4 bonds, meaning 4 lines, so 8 electrons. It's okay for carbon, but if you look at oxygen, you just have 2 bonds, meaning that 2 lines are missing. So we know that oxygen can just do 2 bonds, so it needs 2 other lines that cannot be bonds. That's why we call them lone pairs, meaning they are alone, they are not linked to another atom. So the French for this is doublé non liant. So what you have to know is just this. So we can use structural formula with Lewis, and so we can just add the lone pairs when we have oxygen atoms or nitrogen atoms, whose diagram is this one, or halogens like chlorine, fluorine, and so on. Now the condensed formula is the same for butanol. We have this. Okay, both are the same. The only difference is the CH3. There it's written H3C because C is linked to C. But I think it's better to use this one. So it's condensed because we do not see the bonds between carbons and hydrogen atoms that are condensed around carbons. So it's the same for both other molecules. So what you have to know is this. And what about Lewis? Once again, we could add the lone pairs on oxygen, and this is something that will be really useful this year and next year when we're gonna study how the reaction work. Why do we have a reaction between two reactants, and we're gonna use this lone pair. So I think it's better to be used to draw them on your diagrams. Now next one is this is the skeletal formula. So you have the picture of skeleton because it's just about the global shape of the molecule, meaning that you have this kind of diagram. So as you can see, you have 1, 2, 3, 4 line. So you have 1 point there, 1. So you have 4, meaning you have 4 carbons, because 1 line like this means you have C, C plus hydrogens. So there you have CH3, CH2, 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 and OH. So we do not represent carbons or hydrogen linked to carbon atom, but we represent atoms like oxygen, nitrogen, and the hydrogen, which are linked to oxygen, and so this will be okay, this will be okay, but this you will never see into the skeletal formula. So in this one, as we just have carbon and hydrogen, we just say lines. Just take care of what you do, because one line means you have two carbons. So you have 1, 2, 3, 4, 5, 6, 7. 1 through in this side chain, 1 into this side chain. So we have the 3 ethyl, 4 methyl heptane, like we said. And this is what you have to remind about this. And something we said already this year, it's Cram, diagram with Cram. So we use 3 dimensions to represent your molecules, and you have edges. This one means that this hydrogen goes out of the screen, so it's into your direction, and this one is on the back of the screen. So you can have an idea of the shape of the molecule in 3D, and it's going to be useful to get differences between two molecules. So in this one, you can see this H is in the front of the screen, this one is on the back, on the front. And these lines means that you are inside the plane of the screen. Okay, you are on the screen.